Okay, hopefully you did good on that Chapter 1 test, but we are going to start Chapter 2, and we're not going to do 2-1. Like I said, the author expected you to be able to do Section 2-1 on your own after tests for homework, but they really aren't that important, so I skip all of the Section 1s from here on out. So we are in 2-2, and this whole chapter is about the big idea of limits, and then all the rest of the chapters are derivatives and integrals. So first of all, we're going to start out with, because you had a little exposure to it right at the end of Chapter 1, the definition of limit again. And this is the one you will have to memorize for the test. So, the streamlined version with some symbols in here says that L is the limit as x approaches c of f of x if and only if the following things are true. For any number epsilon greater than 0, there is a number delta greater than 0 such that if x is within delta units of c, but x never actually equals c. That's because sometimes there's a hole in the graph, so we can't ever equal to c. Then f of x is within epsilon units of L. So this is all what has to happen in order for the limit to actually exist. So what is that saying? In a picture, I guess I should say with the graph, we've got a function coming through. Let's put the hole in it, even though it doesn't have to have a hole in it to have a limit. So as I approach c, it will have a limit. Remember, the limit is the y value. As long as for any number epsilon, that's a distance away from the limit. I'm going to exaggerate this. This distance right in here is epsilon above and epsilon below. When I read over, hit the graph, go over, hit the graph, this delta distance exists. So that what it's saying is any number I pick between here and here, when I go up and hit the function, it's between the boundaries there. So this definition, think about it as windows. If I stay within this window, the resulting y value is within this window. If that's true, then the limit exists. And at this point, I just want you to sit back and look at these graphs from the book. Down here, this is page 40, but I just want to explain it real quick. So here's a different function coming through. They've established this epsilon to be 0.8. So you've got this big window here. Hits the graph, hits the graph. And they've just arbitrarily picked a really small delta in here. So if I pick any number in between here, when I go up and hit the graph, I'm still within this window. So this is a good delta. It's just that it could have been a little bit bigger. I could have backed up a little bit farther away. Hold on, Mr. Downey's here. Look for video 2 in a minute.